Hello students, welcome to the first tutorial on static equilibrium. In this video, we introduce the concept of equilibrium and demonstrate how to apply it. Generally, the key topics that you need in order to understand this topic are vectors and forces. However, I will try to explain every step, so even if you don't know these topics, you should be able to follow. Now let's begin. Static equilibrium in this case means objects that are not moving. Or if we focus on equilibrium, what we mean here is balanced. These are situations in which all the forces acting on the object are equal or are balanced. Now, that means when you add the forces in a vector way, when you add them, the sum you get is 0, meaning the forces must cancel out. Now, let's take an object that is on a table. So if you have an object like this, and then it is on a table. So of course, what we know is if this object has a mass, let's say m, it has the weight as a force acting on it going downwards. So the weight is going to be mg. But if this object is not moving, what it means is there must be a force that is opposing this. So from our studies, you guys should recall that the force that will oppose this has to cancel this mg. So the force goes up. It's going to be the normal force in this case, Fn. Now we have two forces acting on this. And if this object, again, if we claim it is in equilibrium, so it means that if we add the two forces, Fn plus mg, the two forces must equate to 0. But then keep in mind, these are forces, they are vectors. So mg is going down. You have to take note of the direction. Since this is going down, this is going to be a negative force. So of course, this then becomes Fn minus mg is equal to 0. Then here, Fn is equal to mg. Now, this is what we mean. The forces acting on a system that is in equilibrium are equal or are balanced. Now, this is one scenario. Let's take another example. Let's say the same object, and then it is on a horizontal surface. And then you have one force that is pulling this side and another force that is pulling this side. So if this is F1 and this is F2, if we claim that this object is in equilibrium, we mean when you add the two forces, they should add up to 0. So you have F1 plus F2. These should add up to 0. But again, these are vectors. You have to take into account the direction. So if we take to the right to be positive, then F1 is going to the right, it's positive. F2 is going to the left, it is going to be negative. So from here, we have F1 minus F2 is equal to 0. Hence, F1 is equal to F2. So the two forces are equal. Now, what you guys should keep in mind is this summation we're dealing with, we are adding vectors. So F1, F2, or mg, the weight, and so on, these are forces, and force is a vector quantity. What that means is force has both magnitude and direction. We have to keep into account the fact that every force that we have to state, every value we have to work with, we have to specify its direction. It's not enough to just give its value. Now, so when we say the forces are equal, or when we add the forces, they should add up to 0. All we're saying is you must add these forces in terms of their vectors. So in terms of the corresponding vectors. So the forces in the X will add up to 0, and the forces in the Y separately will add up to 0. So this is generally what we are saying. So don't just get forces and add them if they're acting in different directions. As in, if your force is in the Y direction and another force is in the X direction, don't add them like that. You have to add the forces that are in the same along the same axis. Now, to help you guys understand what that implies, let's take the same example, but now the forces are in this manner. You have this force like that, and in this force like this. So this is, let's say, F1, and this is F2. So if this is what you have now, you can't just say F2, since F2 is more off to the right, you say F2, and then F1 is more off to the left, you say minus F1, and claim that this is the one that is giving you 0. This is not acceptable. Why? Notice the direction of F2. It is not in the same direction or along the same axis as F1. You must then break down F2 to get a portion of it that is in the same axis as F1. Once you do that, then you can add this force, this part of F2 that is in the same axis as F1. That is the one that is going to add up to 0. So I hope that is clear, you guys. This part where you break down F2 into its, to get the part that is along the same axis as F1, this is what we call resolving a vector, or getting the components of a vector. So F2x here is just a component of F2, or a part of F2 that is in this direction. Now, since it is a part, it must have another part. The other part is going to be this part, the one that goes up. So I used broken lines there. Let me use broken lines as well. So the second part is going to be this part here. So if this is the part along the x, F2 in the x, this must be F2 in the y direction. So basically, this is how you resolve vectors. So if you, resolving vectors is something that we did in previous topics, but if you're struggling with that, I'll make a video about how to resolve vectors to get the components, and I'm going to put a link in the description as soon as I do that. Okay, but don't worry if you are still struggling with that. I'll try by all means to explain every step as I work out this. Okay. Now, the best way to understand this is with an example that actually requires us to resolve this vector. So let's jump right into an example. So let's look at this question. I hope you guys have had time to try this question. If you haven't seen it before, you can pause the video or read through the question and try it out. So I'll give you guys a few seconds to do that. So thumbs up to those who actually managed to get something, and then to those who just want to see how it's done. Let's get started. Okay, so the question is asking us to get T1, T2, and M2. So T1 is this force here, and then T2 is this force here. M2 is the mass of this object here. And then M1 is given in the question. M1 is 10 kgs. Now, how do we do that? The key thing is this assumption that we're given here. You guys have to keep this in your mind. The question actually specifies that assume they're saying we have to take the pulley to be massless. So they're saying we take the pulley to be massless. They actually even go on to explain what that means. It does not change the tension in the cord. This means that the tension here is the same as the tension here, T1, T1. So once we know the value of the tension here, then that tension will be the same throughout the string. It would have been a different case if this pulley was not massless, if it had a mass. Using the knowledge from the previous topic, we could have been able to see how this influences or changes the tension in the string. But basically or generally, what it would mean is if this was not massless, work would have to be done to make this pulley rotate as the system comes into equilibrium. So some force would have been lost over the pulley. Yeah, basically that's in a nutshell, that's what that means. But in this case, the tension in the string is maintained. So T1 here is the same as T1 here. Now, how do we get T1? You see, in this case, we're given a lot of information here, or given actually all the information here. So it's easy for us to get what T1 is. So let's look at this part. For M1, what we have is the weight going down. So that's M1G, and going up, the tension. And we say that is T1. So when we add the forces for acting on the mass M1, we see that those are forces in the Y for that particular mass. So the sum of the forces in the Y for M1, remember here I'm just isolating M1 to get how the forces in the Y behave there. What we observe is we have T1, let's take up to be positive and down to be negative. Then we're also going to take this direction to the right to be positive, meaning to the left, it's going to be negative. So in this case, T1 is going up, it's going to be positive T1. Then M1G is going down. This is going to be minus M1G. So remember this, the question says these are in equilibrium, meaning they add up to 0. So from here, we know what M1 is. It's 10 kgs, so it's minus 10 multiplying G. Let's take G to be 9.8. So we're taking G to be 9.8. So this is times 9.8. So this must be equal to 0. So hence T1 is equal to, we can actually evaluate this before we move it to the other side. So this is going to be 98 is equals to 0. So you can conclude that T1 is equal to 98. So since this T1, it's a force, so the units here, I hope you guys know the Newton. Okay, so we found one value that the question was asking us to find. Let's start hunting for the other ones. So to get what T2 is, now we're going to come to this point here. So now we're going to concentrate at this point. So we want to get this point. Identify all the forces that are acting along this point. So draw a free body diagram so that you can easily see the forces that are acting there. So you see that the weight of M2 going down will be the one that will act through this strain. It becomes a tension here. So that is going to be the weight that is here. Then next up, we have T2 pulling this side, and then we have T1 going this side. So how does it look like? So basically what you're saying is you have the x-axis going this side, the y-axis going up, and then from here, what we have is T1 going in this direction, T2 going there, and lastly, the weight of M2 going down. So this is T1, this is T2, and then this is M2G. Now this is the part where we're saying to actually work out this now, we have to resolve them. So we want to resolve them. After we resolve them, then we're going to add the components and equate them to 0. So to resolve these vectors, this angle is given as 45 degrees, and this angle is given as 53 degrees. Okay, now how do we resolve them? We must get a part of this force that is in this direction. So let me write the components using a different color. So we must get the part of this force that is going in this direction, and then get another part of this that is going in this direction. These are going to be the components. So this is going to be the component of 1 in y, and this is going to be the component of T1 in x. And then when it comes to T2, to resolve this, we're going to get a part of it that is in this direction. And then after that, we're going to get a part of T2 that is in that direction. So this is going to be T2 in y, it's pointing along the y-axis, and this is going to be T2 in the x. Okay. Now, the easiest one to work out here, if you look at the way it is, the x-axis looks like the easiest one to work out, because along the x-axis we know how to find T1x, And since here, the only thing that we want to know here is how to get T2x. Okay, now let's focus on this part, on this triangle here. So if you are struggling on how to convert this, how to get T1x, so what is happening here is, if I was just to get that triangle, so this is a right angled triangle. So we're going to use the trig ratios. So because this is a right angled triangle and the angle we're given here is 45, and then we know that this is 98, or we can say that is T1. So let's say we wanted to find T1. This is what we want to find first, T1x. So to find T1x here, so here we're going to use cos. These two are adjacent to each other. So here we have to use cos. So here it's going to be cos the angle 45 degrees. So it's adjacent, it's equal to the adjacent T1 in x over the hypotenuse. The hypotenuse is 98. So from here, when we cross multiply, this is over 1. We see that T1 in x is equal to 98 cos 45. So this is what T1x is. Now, we can also get what T1y is, since we can use this for those who might still be struggling with resolving these vectors, but we'll use T1y later. I'll just resolve it now. T1y here, the two are opposite. The angle and the side, they are opposite to each other. So what you guys should notice is sine is the one that works with the opposite side. So sine 45 degrees is equal to T1y over the hypotenuse 98. So this then, when you cross multiply here, you have T1y is equal to 98 sine 45. Now you can go on to complete these operations, but I'm leaving them here. I'll complete them when we use them in the last part. So using the same idea, when it comes to this triangle here for T2, so what we have is something like this. So let me try to make it a little bit more visible. So what we have is T2 itself is going like that. And then here what we have is T2 in X. And then here what we have is T2 in Y. Now this angle here is given as 53 degrees. We have no idea what T2 is. That's what we want to find. So if we had wanted to resolve this, so to resolve this again, for T2 in X, what we are saying is these two are adjacent. So we're going to say cos the angle, that's 53, is equal to the opposite, the adjacent. So that's cos the angle is equal to the adjacent, that is T2 in X, over the hypotenuse, that is T2. So from here, want to get T2 in X, cross multiply. So we get T2 in X is equal to T2 cos 53. And then if we wanted to get T2 in Y, I hope you guys have seen, you can use the same idea I used the other side to get it, but I hope you guys are able to show that T2 in Y is equal to T2 sine 53. Now, I hope you guys should keep one thing in mind. When it comes to T2, the component T2x is going to the left. So when it comes to using this component, we'll have to keep in mind that it is going to the left. So it will have to be negative. But I'm reserving that for when we'll have to use it. Here we're just working out what it is. But when using it, we'll have to keep in mind that it is going to the left. Okay, so I used this to just help you guys remember how to resolve vectors. Yeah, but let's look at what we have to do, how we're going to make use of what we found here. So let's go back to our diagram. So remember, the system is in equilibrium. If it is in equilibrium, what it means is the forces add up to zero. When you add the forces in the vector way, they should add up to zero. So when you add up the forces in the x-axis, they must add up to zero. And which ones are the forces in the x-axis? You have T2x and T1x. Those are the only two forces in the x. So these two forces must add up to zero. So we're going to have this plus that equals to zero. And then we go to the y. In the y-axis, what you have, I hope you guys are able to see them. Try to identify them. I hope you're able to identify them. So we have T1y going up, so it's going to be positive. T2y going up, it's going to be positive, plus M2G going down, so it's going to be negative. Okay, so those are all the forces in the y. So let's start with the x. So in the x, we saw that we had two forces. T1x was going this side, and then T2x was going this side. Then that was the central point. So because T1 is going to the right, T1x is going to the right, it's going to be positive. T2x is going to the left, it's going to be negative. And then these add up to zero. Okay. Now, what is T1x? So T1x, what we have, you guys can just check through. We had 98 cos 45 for T1x minus T2x. For T2x, what we had was T2 cos 53 is equal to zero. So from here, what you guys should see, we just have to make T2 the subject of the formula, so we can make this cross the other side. So now we have this, and then the negative becomes a positive. Then here, divide both sides by cos 53. Now we have 98 over cos 53 is equal to T2. So here we're saying T2 is equals to 98 cos 45 divided by cos 53. So if you work this one out, you should get T2 as 115 newtons if you use three significant figures. Okay, so we found T2. Now the next part, the question is asking us to get what mg is. Now, how do we get mg? So for mg now, we worked with the x-axis. Now we have to go to the y-axis. So you guys recall, we identified three forces which were going up, which are going in the y-axis. We had, I can use somewhere here. So we had something like this. So we had mg, m2g going down. And then somewhere here we had T2y going up. And then here we had T1y going up. So these are the forces which we had in the y-axis. So if we take this into account, T1y going up plus T2y going up. So these are positive, they're going up. M2g is going down. So you want to say plus, then minus. That is just going to end up as a minus. It is going down. M2g, these equate to zero. So when we substitute here, what I have is T1y, this is going to be 98 sine 45 plus, and then this is T2y. So T2, we didn't know what T2 was, so that's just T2. And then this is sine 53 minus, and then this is M2g. So we don't know what M2 is. but we know G is 9.8. So G is 9.8. So that's times 9.8. So from here, these are equals to 0. So we want to make M2G, or the M2, the subject of the formula. So this is going to be 98 sine 45 plus, we've already found what T2 is, so you can also substitute it. T2 we found 115. So this is plus 115 sine 53 is equal to M2 times 9.8. You can divide both sides by 9.8. So what you now have is 98 sine 45 plus over 9.8 is equal to M2. So from here, if you simplify, what you're going to get is 16.4 is equal to M2. So therefore, M2 is equals to 16.4 kgs. Okay, so with that, we worked out all the quantities they wanted us to find. They wanted us to find T1. We found it was 98 newtons. Then they wanted us to find T2. We found T2 as 115 newtons. And then lastly, they wanted us to find M2, and we found 16.4 kgs. So these are the quantities that we found. So yeah, I hope you guys were able to follow this. Let me know how you found it. Let's say for those who were seeing vectors for the very first time, let me know how easy or what you found hard about them, so that as I make the next video, I know which part to explain more on. So if there's something that you want me to just emphasize on in the next video, just let me know. For the next video, I'll be working out another example on this so that you guys can better understand this. So you guys are free to try it out. It uses the same concepts, just like in the previous one. We're saying you're assuming that the pulleys have no effect on the tension in the cord, so you should be able to work out this question as well. So try to look at it, try to attempt it. Otherwise, we'll see you in the next video. This was your tutor.